Hello and welcome to our last lesson on radicals. And then Mr. Simpson retires. I'll have had enough of him. Okay, so in this section we're going to be rationalizing radical expressions. And one of the key rules when you are rationalizing radical expressions is that you may not have a radical in the denominator. So it's going to be our job to remove that denominator or that radical from the denominator, and this is how you would do that. So the steps are, number one, you're going to multiply the numerator and denominator by a radical that will get rid of the radical in the denominator. Then the second step is you're going to make sure all your radicals are simplified, and finally simplify the fraction if it's needed. So let's go through the process. So now we're going to look at example 1. And in example 1 you can see that radical 2 is in the denominator. So the first step is multiply the numerator and denominator by a radical that will get rid of the radical in the denominator. So what could I multiply radical 2 by to get rid of the radical? If I multiply it by itself, I get radical 4. But if I multiply the denominator by radical 2, I have to multiply the numerator by radical 2 as well. 1 times radical 2 is radical 2. So now I can go ahead and I can, step 2, simplify my radical. Radical 2 over the square root of 4 is 2. The third step would be to simplify the fraction, but there's nothing that I can do to simplify it. So this here is going to be my final answer. In the second example, I see that I have radical 7 in the denominator. So what I want to do is multiply both the numerator and denominator by radical 7. So this time I'm just going to go ahead and put radical 7 in the numerator and radical 7 in the denominator. I'll multiply across the top and I'll get radical 14. And then I'll multiply my bottom. Radical 7 times radical 7 is radical 49. Then I'm going to simplify my radicals. There is no perfect squares in radical 14, so that's going to remain as radical 14. The square root of 49 is 7. And I cannot simplify my fraction, which is the third step. Therefore, this is my answer. In our last example, I have radical 6 in the denominator. To get rid of the radical 6, I'm going to have to multiply both the numerator and the denominator by radical 6. So multiplying my denominator, it's going to be 2 for my coefficient. Radical 3 times radical 6 is radical 18. Radical 6 times radical 6 is radical 36. Now I'll simplify my radicals. 2, there's a perfect square in 18, which is 9, so I can make that radical 9 times radical 2. Because radical 9 times radical 2 is radical 18, so I'm just breaking that apart. The square root of 36 is 6. Now we have some cleaning up to do in the numerator. 2 times the square root of 9 is 3, radical 2, over 6. And then I'm just going to bring it down a little bit because I've run out of room. 2 times 3 is 6, radical 2 over 6. So I've simplified all of my radicals, and my final step is going to be to simplify the fraction if needed. I can see that I have both the 6 in the numerator and the denominator, so I can simplify those and it becomes 1. So my answer will be radical 2. Now I'd like you to try some of these examples. The first thing I would do with the first one, though, I would note, is I would do some simplification before I started going ahead and rationalizing the denominator. In this situation, I see I have a 3 and a 6. Those reduce down to 1/2. And then I have radical 20 over radical 15. So they're both divisible by 5. Radical 20 divided by 5 becomes radical 4. And radical 15 divided by 5 becomes radical 3. Continuing on, I have radical 4 in the numerator, so it's essentially 1 times the square root of 4, which is 2, over 2 radical 3. my numerator now becomes 2, and my denominator is 2 radical 3. So this is not finished by any means. I want you to go ahead and carry on from here. But I just wanted to show you that sometimes you can clean up a little before you start rationalizing, and this is one of those situations. So go ahead and finish this problem and try the next two. Thank you.